Okay, welcome back, guys. So just chatting with the ones here, going over a couple of things. So just as a reminder, your one revolution counterclockwise at each of these axes. That's the degree measure, that's the radian measure. And just a reminder on how to convert from degrees to radians, but a lot of topics to cover for right triangle. So in right triangle trig, I've skipped 4-2 on purpose in terms of the way I want to present this. I think it's better to do right triangle trig. 4-2 is what I'm sure you guys all know and love, but the 4-2 is the unit circle. So I'm sure you don't mind putting that off if you've seen unit circle before. It's better to learn it this way. Have you done unit circle before? The thing that looks like a wagon wheel? Okay. Which I think is a horrible way to learn. I'll show you what I think is better. Because you see that wagon wheel, you get intimidated. They try to get you to memorize all these points, and it's just not going to happen. There's only 4 points or 4 that we'll memorize. Okay, so getting started. All right, so right triangle. Right triangle means one of the angles is a right angle. So once that we understand that we're working with a right triangle, now we know something about the other angles. What do you know about the other 2 angles, Spencer? It could be the same, but what do we know? Not what could be. What do we know for sure about the other 2 angles? Anybody? They have to equal 90. Why do they have to equal 90? That's exactly right. So you know if this is 90, then this angle and this angle here have to add up to 180. So whatever I want to use, if I wanted to use alpha and beta, alpha plus beta must equal to 90, because alpha plus beta plus the right angle must equal to 180. So alpha plus beta plus our right angle must equal to 180. Sum of the interior angles of a right triangle, or any triangle, is 180 degrees. So one thing what do you call that? There's a word for that in geometry, which they don't teach you anymore. They just call it integrated math. What is the term for 2 angles that their sum is 90 degrees? Complementary angles. Those are complementary. Okay? So these 2 angles are complementary. This is 40, this is 50. If this is, what's the only situation where they're going to be the same, Spencer? 45. Okay? 45. But if this is 30, then this is, yeah, there you go, or whatever, right? But you got the idea. Okay. So when we go, I use Greek letters for the internal, for the inside, but for the vertices, we use capital letters. So this would be triangle ABC. Okay, and you could call this. So in lieu of me calling angle A, I call it alpha. See, so I'm reducing the words into symbols. So instead of having to write angle A, we just write alpha. We use the first Greek letter. In lieu of writing angle B, I write beta. Beta looks like a capital B with a longer tail there, a longer vertical part. And then if you wanted C, if we did have an angle C, it would be gamma, but in this case we don't need it because we know it's 90. But gamma is what you use for the third, that's the 3rd letter of the Greek alphabet. So we use gamma for angle C. So you'll see that a lot, especially when we get into triangles that are not right triangles. Okay? So this triangle ABC. Then the sides, so now if we have our triangle ABC, the side opposite of angle alpha is little a, the side opposite angle beta is little b, the side opposite angle C is little c. Now, notice we use lowercase letters for the sides, capital letters for the angles, or Greek letters for the angles. Okay. All right. Now I can use alpha, beta, gamma. I'll also use theta and phi, as I mentioned in the videos last week. You can also use theta and phi. Okay. All right. So now let's talk about the ratio. So all those that sine, cosine, tangent, and you've heard of, it's just a ratio of sides. So instead of me labeling the triangle like this, let me just draw the triangle, the right triangle, where we only highlight this angle here. We call this angle theta. And then let's label the sides not with the A, B, and C, but with the words pertaining to that angle. So the opposite, the hypotenuse, and the adjacent. So if this is our 90, then what side is the hypotenuse? Yeah, the one across from the 90. So this is the hypotenuse. And then you have left, and we're referring to this angle theta. So if this is angle theta on these two legs, which one will be opposite? One across from it, right? And then the one next to it is the adjacent side. Now, had I gone to this angle and called this angle theta, I would have had to change how I label it, right? What would have changed? Right, hypotenuse would not change. Okay, so now from this angle, let's see if you can do sine theta, cosine theta, and tangent theta. You can use OA and H if you want, if you don't want to have to write the words out, or you can write the words, okay? Whatever you want to do, write those three ratios down. Which one is which, okay? See if you can remember. If not, we're going to put it on the board in a second. Okay, so what is sine theta? Sine is what over what? Do you remember what two sides? Opposite over hypotenuse, right here. What's cosine theta? Over hypotenuse. What's tangent theta? Okay, now, what, let me ask you this. If the hypotenuse is the blank side, so hypotenuse is always the what side? In terms of length? Longest. Sine and cosine can never be greater than what? If the hypotenuse is the longest side, then the sine and cosine answers can never be greater than what? 1. Has to be less than 1 because your denominator is bigger than your numerator. Less than 1. Okay? That's important to know. All right. Now, typically, these are the only trig ratios. When I ask students the trig ratios, this is what they give me. Notice there's how many trig ratios? 6. So what are the other 3? No, that's something different. Those are, there's still 3 other trig ratios. So it's better to know them in terms of their reciprocals. The reciprocal of sine is called cosecant. We write it like this, CSC. It is not the inverse sign. That's something different. I'll talk about that later. So cosecant is written CSC. Secant is written SEC. And cotangent is written COT. And those are the 3 reciprocal identities. I've written them in the order in which ones they're the reciprocal of. So cosecant is the reciprocal of sine, so therefore it's H over O. Okay? So secant is the reciprocal of cosine, so it's written H over A. The reciprocal of tangent is cotangent, which is A over O. So I really only memorized the first 3 and I just flipped to get the second 3. I got to know which one's flipped though. Okay? So we'll get to the inverse ratios later on what we use those for, or inverse functions, but this just tells us our ratios. So when we get to a problem, we're going to do one here in a second, and we'll go through and make sure that, and we'll write these out. There's no button for this on your calculator, but I will show you how you can type it in on your calculator in a little bit. You don't use the -1 button. That is something different. So don't confuse that. So you should see this button on your calculator, right? With the sign. That does something else. So I'll get to that. So don't confuse that. This is not this. Inverse sine is not cosecant. Okay? All right. Okay. Well, we've got the 6. So what's the little, how do you say this? What's the like SOH, CAH, TOA, what do they call it? SOHCAHTOA, right? This is his cousin, Choshakeo. Okay? So just in case you didn't know, see, you really know trig if you say, I know their cousin, Choshakeo. Okay? See, Cho, Sha, it's Keo. C-A-O, I pronounce it Keo. All right? But like I said, I don't do that. That is what's in my hard drive. That has to be there. And then this is in my hard drive. That this guy is the flip of sine. Whatever sine is, flip it, I get cosecant. So then, sine and cosine can never be larger than what number? 1. Therefore, cosecant and secant should be larger than 1. Very good. Okay. What next? What do we need now? So I'm going to erase that because I think at this point, even the ones at home can have it in your notes. Okay? All right, so we've got our triangle there. We've got our 6 trig ratios. I should have left the triangle. We need one more thing that is important about a right triangle that I know you're taught early on, and we'll just look at those sides that we had. What's the theorem that relates to 3 sides of a right triangle? Pythagorean Theorem. Okay. And it says what? Okay, very good. Okay, there's that. And I'm not going to go into that, but even you remember when we had Dr. Stevens on, he was talking about the Pythagorean Theorem, I think. So, but you can go a lot deeper into that. Now, here's what we're going to do. So example 1. You're going to work this problem where it's got missing parts. Okay, so let's say this is our angle theta. So we're going to go from this angle here. And let's say that this side is 3, this side is 1, but we don't know C. So part A, first thing we're going to do is find the missing side. Part B, find the 6 trig ratios of theta. So from theta, we're going to find sine theta, cosine theta, tangent theta. And then I find those 3, and then I just flip to get the other 3. And then we will look to rationalize. That means if we won't leave a square root in the denominator, we will just add that on just so you know how to do it. Okay, so go ahead. Now, how are you going to find C? You're just going to use Pythagorean Theorem. So make sure you can get C first. Find C, because we need this. Otherwise, I can't do opposite over hypotenuse. All right, get your C, and then work the problem, okay? Find the 6 trig ratios. Go ahead. You want to circle your C so I can check it to make sure you got it right. Good. Good. So that's where it's 9, that's where it's 1. So that's where it would be 10. You need not that side squared, you need the square root of it. Just write it down. Yeah, just think about that. Just don't write it down. It's in your rounding. Yeah. Got it? Huh? Well, it'll be on the ground. I don't think it's gonna get warm enough to melt off the ground. Yep, your stuff looks good. You get your 6 trig ratios? Oh, yeah, you're good. You get, side C?
I don't know, with my calculator.
You don't need a calculator. You won't be able to use it, because you wanna leave it exact. Write it out, fill out the Pythagorean Theorem. You got it. Yeah. You don't see me up here with a calculator. If I'm not using one, you shouldn't use one. I keep forgetting this is a long class, so we'll probably finish this early. That'll give me time to go in and adjust the assignment, then I'll open the assignment for you. We need to adjust it a little bit. Okay. So Pythagorean theorem is pretty much just plug and crank. I gotta find that side. So 1 squared plus 3 squared is c squared. 1 and 3 squared is 10. So if I want c, I'm gonna do what to both sides? Square root. So c is the square root of 10, and I just leave it, square root of 10. Why don't I want to put a decimal? Because you're rounding. Square root of 10 is exact. Since square root of 10 is irrational, if you type it in on your calculator, then you're rounding the number. By leaving it square root of 10, we leave it exact. So when you see the answer, write the exact ratio, you know to not put a decimal. Okay? So now, I'm just going to go from here and I'm going to do sine, cosine, tangent. So let's see. So what's sine of theta? Before you rationalize, don't rationalize, just give the two sides. Go ahead, Austin.
3 over square root of 10.
All right. What's cosine theta? Go ahead, Austin.
1 over square root of 10.
What's tangent theta?
3 over 1.
Okay, very good. But you would then make 3. Now, if we say rationalize, rationalize means rationalize the denominator. Don't leave a radical. So sometimes they'll require you to rationalize. I'm not a big fan of it. I think that's good enough. But means that you don't leave a square root in the denominator. So what you do is whatever the denominator is, you multiply the top and bottom by that. And so now we get 3 square root of 10 on top, and now the bottom becomes 10. Now I prefer this answer over this answer just because it's cleaner. But just so you know what rationalizing is. Okay? I'm gonna flip from here, because when I flip, then I won't need to rationalize anymore. See, so cosecant is the flip, and I'll flip the original. So I'll put square root of 10 over 3, which now, by flipping, there is no radical in the bottom. All right, secant would be what?
Square root of 10 over 1.
Yeah, so we just leave it square root of 10, and cotangent is what?
1/3.
1/3. There you go. So you see, you'll have a 2-part problem sometimes. You'll have to go and, what's the word I'm looking for? Find the missing side, and then you got to finish the triangle, find the sides. Okay, now, what if I asked you this question? Find the sine of 90 minus theta. So first of all, let's break it down. If you see SIN, this in here has to be an angle, and somehow you have to do opposite over hypotenuse. Okay, so just to make sure that we're clear. If you have SIN here, that's sine. That inside has to be an angle, and you have to do opposite over hypotenuse. Okay? The question is, what angle is that? that?
Theta.
It's not theta. That's theta.
Theta. The
Yeah.
other angle.
All right, it's the other angle. How do you know? What did we say about these two angles? They gotta add up to 90. So think, if this is 20, this is 70. Or 90 minus 20. Then you would say 70. If this is 20, you would do 90 minus whatever that one is to get this one. So that's why, since this is theta, this angle is 90 minus theta. It's the other angle. It's the unlisted angle. So, all right, so I'll go here. So what is sine of 90 minus theta? So you would go to this angle and you do your SOHCAHTOA. So from here, you got to know opposite and hypotenuse. So what's your opposite now? 1. 1 over square root of 10. Okay. All right. So when I get to the end, I'm going to make some identities that will be helpful. I like to just teach the topic first, and then we'll go back and we'll look at some of those identities. Okay. Example 2, we'll work on very similar to this, and then let you, so here's example 2. Here's your triangle. Let's now call this theta, so we don't always feel that the bottom angle has to be theta. Let's call okay, there you go. So this is side A, so part A, find the missing side. Part B, evaluate the 6 trig ratios of theta.
So the square root of 2 is just, like, the square square root is just, yeah.
Did any of y'all get charged for your dual normal class? I've had 3 other people that got charged. Like their grant didn't go through or something. Huh? I got charged like 500 something, but I've had someone that she was like, I got charged like $3,000. I was like, oh my goodness. For what? Oh my goodness. Yeah. So you said for English? And I was like, maybe? Yeah, and my mom was like, they said they're charging you out of state tuition. And I was like, I don't know.
Okay, so let's look at this. So we'll do this one. So let's see, side A. So I'm going to do a squared plus square root of 2 squared is 5 squared. All right, so let's see, a squared plus 2 is 25, subtract 2, so a squared is 23. So if I take the square root of both sides, a is the square root of 23. Okay, so you should have got square root of 23. And now I do all my SOHCAHTOA. So now I go from theta. So sine of theta is square root of 23 over 5. Cosine of theta is square root of 2 over 5. Tangent theta is what?
Square root of 2 over the square root of 23.
No, other way around. Square root of 23 over square root of 2. Which now it's kind of odd looking like that. So it would be better to rationalize. If I rationalize, I multiply top and bottom by square root of 2, I'd get square root of 46 over 2. When you multiply square roots, you multiply the inside, so that looks much better. Okay. And then you just flip. So to get the other 3, I just flip. Cosecant is 5 over square root of 23. Secant is 5 over square root of 2. And cotangent is 2 over square root of 46. Okay. All right. And then I can rationalize again if I need to. Okay, so we got the idea on this type of problem. Any questions about that? Okay. So we've got our 6 trig ratios. We've got the Pythagorean theorem. Now let's talk about special triangles. So okay, so 2 triangles where the sides and the angles are known, or the ratios and the angles are known. One is called a 30-60-90 triangle, and one's called a 45-45-90. All right, so on a 45-45-90, it would be 1, 1, square root of 2 are the sides on a 45-45-90. And on a 30-60-90, it's 1, square root of 3, and 2. So the 1 is opposite of the 30, square root of 3 is opposite of 60, and 2 is opposite of 90. So these are the reduced sides on a 30-60-90 and a 45-45-90. And then from there, we can now use the angle to ask specific questions. So I may just say, find sine of 30, cosine of 45, tangent of 60. See if you can do those 3. Now you know which angle to go to, and then you need to do the proper SOHCAHTOA at each of those angles, and see if you can then find those answers. So let's go through these. Sine of 30, Andrew. Sine of 30, we go to 30, then we gotta do SOHCAHTOA. So opposite over hypotenuse, we should get what? 1/2, all right, okay? Cosine of 45. Anybody? 1 over square root of 2. I like leaving it like that, because but you can rationalize it, make it square root of 2 over 2. Tangent of 60. Square root of 3, very good. So the 60 do opposite over adjacent. Now let's talk about our calculators, right? So go ahead and grab your calculator out and then type these in and see if you get the same answer. Now go to mode and make sure that you're in degrees first, okay? You need to be in degree mode, okay? So go to mode and make sure you're in degree. Then you just type it in, sine 30, you should get 1/2, okay? You should get 0.5, all right? Cosine of 45, well, it won't give you an exact, it will give you the decimal equivalent of 1 over square root of 2, which is about 0.707. So just see real quick, okay? See if that's what it gives you. All right, guys, make sure you're all typing, because I'm going to show you something. If you have your calculator, type it in, okay? Now, here's what I want you to see. You were asking me about the inverse sine button, Spencer, okay? So a couple of things. First of all, notice there's no buttons for secant or cosecant or cotangent. But let's think about this for a second. Because I just want to make sure that we're clear on how to, because sometimes we won't know we know the angles, but we may not know the sides. So how can we type it in on a calculator? You know, for instance, if we have this triangle, say this is 40 degrees and this is 50 degrees, well, we don't know the sides. So if we want sine of 40, we just got to type it in. I'm using this right now because this helps, because we know the answers we can verify, okay? So notice if sine of theta is O over H and cosecant of theta is H over O, then these are reciprocals. And reciprocal means 1 divided by. If you do 1 divided by, then you reciprocate. So for instance, if this is 1/2, if sine of theta is 1 over 2, then cosecant what? Should be 1 over 1 over 2. Reciprocal means 1 over whatever this is. Well, what's the rule? When you divide, you can flip and multiply. So 1 over 1/2 is the same as 1 times 2 over 1, which is 2, which is what cosecant should be. So what we're going to do is this. We're going to connect these two with a little rule. So if they're reciprocals, sine should equal to 1 over cosecant, and also cosecant is equal to 1 over sine. This is what it means to be reciprocals. So notice, I don't have a cosecant button on my calculator, but I know that the cosecant of 30 degrees should equal to 2 because it's the reciprocal of sine. So if you want to get cosecant on your calculator, just do 1 over sine and that should give you the answer. So if I'm going to do cosecant of 30, I don't have a cosecant button, but I'm going to do 1 over sine of 30. And that should give me cosecant. Okay? All right. And here's the other one. So these are, I'm going to write these down. I'm going to store these 6 reciprocal identities. So sine of theta is 1 over cosecant theta, and cosecant of theta is 1 over sine theta. So if you want to do cosecant, you do 1 over sine. Cosine theta is 1 over secant theta, and secant theta is 1 over cosine theta. Tangent theta is 1 over cotangent theta. Cotangent theta is 1 over tangent. So now, let me ask you some of these, and you use these buttons to type in just to verify. So let's say you wanted secant of 45, or you wanted cotangent of, cotangent of 60, that's fine. Say you wanted those. I mean, you should be able to get the ratios by hand, but you should also be able to use the calculator. Okay. Okay, so real quick, you don't need a calculator for these, you can do them without, but let's just see, what's secant of 45? So it doesn't matter what 45 I go to either one. Secant is hypotenuse over adjacent, so I should get square root of 2, or the flip of cosine. Cotangent of 60, it's the flip of tangent of 60, so I should get 1 over square root of 3. I don't know what those decimals are. This one I know, you should have got 1.414 on your calculator. I don't know what 1 over square root of 3 is. Okay, so now let's test and make sure that you can do this correctly. So you're in degree mode, do cosecant, secant, and cotangent of 40 degrees on your calculator, and let's round to 3 decimals. Okay, just share with us and we can all check. What did you get for cosecant of 40?
I got
1.556. Does it make sense that it's greater than 1? Yeah, because it's a hypotenuse is on top. What about secant of 40?
Yeah, 1.05.
1.305? What about cotangent of 40?
1.192.
1.112. Very good. Okay. All right. So does everybody see there? You don't use a button. You got to do 1 over. It's reciprocal relationship to get that. So now the question would be, well, what do I use those -1 buttons for, right? So why might I do that? So, well, let's look at a couple of things. So let's just say, well, let's go straight to it. So let's just. The question, is this still a 30, 60, 90 triangle?
Yeah.
Yes, okay. But I'm gonna pretend that we don't know this angle. And that's what that button does, okay? So for instance, we know that sine of theta should be 1/2. So the way sine works is you type in an angle and it gives you the ratio. So you input angle and output is ratio, okay? That's how that button works. The way the inverse sine works is like this. You input the ratio. You do inverse sine and it works backward. It gives you the angle. So the inverse button is a work backwards. You give the ratio, it gives you the angle. So if you type in inverse sine of 1/2, it shouldn't give you a ratio, it should go back and give you the angle. It should tell you what the angle is for that. So those buttons on the calculator, the inverse buttons, give you the angle. So if I do inverse cosine of, if I do inverse cosine of 1/2, I should get 60 degrees. If I do inverse sine of 1/2, I should get what? 30. And that's what it does. So these buttons, how do they work? You input the ratio, your output is the angle. It works backwards. Okay? So I'm going to show you in a second why we might need that. Okay, so you're gonna do some simple calculator problems that you're going to get. Okay, I'll just show you a couple here. So a couple of terms that you may get or as you work some problems. So let's just say you had a tree or something here. Okay, so any measure to the top of something from a horizontal to the top is called an angle of elevation. So if you see that you know that we're measuring from horizontal up. We're going to take a break here in a second, and then I'll finish the lesson, give you a little time. All right, so if you see angle of elevation, you're thinking that's from the horizontal up, we're taking that measure. And then if you see angle of depression, that's from horizontal down. Okay. So it's now you know, like we're looking at a side view of a picture. Okay, so if I do angle of elevation, horizontal up, angle of depression, horizontal down to some target. Here, of course, I did a guy in an airplane looking down, and here we're looking to the top of a tree. So a typical problem that you're going to get, you might get something like this, where maybe you wanted to tie a rope or something to the top of a tree or something. You wanted to bring a rope down, or you want to find the height of the tree. Let's just say this. So let's just say, we'll go, I'll just redraw it here. Here's your tree, and you know that you're standing, say 50 feet from the base, and you know that the angle of elevation to the top of the tree is 21 degrees, and you want to find the height. Okay? So these are very simple word problems, and I'm going to show you how we use trig to find it. So first of all, is there a right triangle that relates everything in this problem? Do you see a right triangle? Hopefully if the tree is going straight up, right? So the first thing I do is, once I find my right triangle, the first thing I'm going to do is write a trig equation involving knowns and unknown. So when I look at this, let's see, I've got an angle. I don't know this side and I know this side. So now let's fill in more specifically. I know this angle. I don't know what side is this in reference to the angle. This is opposite. This is. So what trig ratio can you write out for 21 that would involve these two sides? I would use tangent. You could also do cotangent, but I think tangent's easier because we have that button on our calculator. So first thing we're gonna do is write the trig equation that relates these three things. So we can see that the tangent of 21 degrees should be what over what? H over 50. Okay? So everybody see why, number one, why we chose tangent and why we put everything where we did. We just picked one that we knew would relate all these. If I had this hypotenuse, I probably would have used sine or cosine, depending on what I had. Then once you write the equation out, then that's it. Then just solve for unknown, and you'll probably need to use your calculator. So all I'm going to do is cross multiply my 50. 50 times tangent of 21 equals to h. And then you should have it round to 2 or 3 decimals. that tick mark is feet, and that's a very, I'm gonna do more of these in the second part of the lesson here in a little bit, but that's just a basic idea there. Okay. What answer do you get? Tall tree problem, or not very tall tree.
I got 19.19.
19.19 feet. So if it is a word problem, make note of the units, because they may want you to type the units in. Okay. All right, now, let's just say, different situation, because I want you to see where you need that inverse button on your calculator. Let's say now that this isn't a tree, but this is a light pole. And I'm running a line from the top of the pole to this point. And let's say that we know this is 60 feet here, and this line is 72 feet. And the question is, find the angle of elevation. Okay, so we want to find how far is it from the horizontal, what's this angle at right here. Now, nothing changes. I still write a trig equation involving knowns and unknowns. So, let's see what we have. We have this angle, we have this side and this side. So what I want you to do is write out, and I would typically use sine, cosine, tangent because those buttons exist on the calculator. So what trig ratio can you write out that involves theta, 60, and 72? So I would go from here and I'd ask myself, hypotenuse, adjacent, or opposite? Yes, so you could say cosine of theta equals 60 over 72. But here's the problem. I need theta. That's what that inverse button does on your calculator. So if you know the ratio, which you do, 60 over 72, so if you want to find theta, you use the work backwards button, put your ratio in, and it should tell you what your angle is. Make sure you're in degrees. So I wanted you to see a problem where I use the inverse button on the calculator. And this is a good example of where I use it. Oh, it's mama. Get all your stuff. Still snowing. Slick out or just easy stuff? All right, cool. Yeah. See you. Still snowing, though. It's still pretty. Okay. So what did you get?
33.55 degrees.
33.55 degrees. And that's your angle of elevation. So does everybody see the use for these buttons? When you use this button when you're trying to find an angle. Okay? So let's stop there. Let's look at what we've got. So have we talked about special triangles? Yes. Have we done Pythagorean Theorem? Yes. Do we know our 6 trig ratios? Yes. Using a calculator to find unknown sides and angles? Pretty much yes. The only other thing I want to give you are, we've done the 6 reciprocal identities. We're going to derive the 6 cofunction and 2 quotient in a second. It's going to take like 10 minutes. But I want to break this up because we're already at a 50-minute lesson. Okay, so let's stop this real quick. Yeah. And we'll pause.